Hello again. In this video, we are going to learn about the inverse of 2 by 2 matrices. So we have a matrix A, which is 2 by 2, and you know that generally this is the structure of a 2 by 2 matrix A, just 2 row 2 column. Now I inverse is defined as this formula. We saw it before: 1 over determinant times the adjugate of A. And determinant of 2 by 2 matrices, you know it. This is how you find it. It's AD minus BC. Okay, AD minus BC. That's how you find the determinant of 2 by 2 matrices. Now, to get the adjugate, what do? You exchange these two, A and D. You put A in the place of D, D in the place of A, as you see in the matrices I wrote. And then you give opposite sign to D and to B and C. You see, I gave B opposite sign and D opposite sign. And then you simplify this, you get the inverse of A. Now, we can apply this on an example. A. First, you will need to compute the determinant, which is 1 times 5 is 5, 2 times 3 is 6, and it is negative 1. That is the inverse. Sorry, the determinant. To find the inverse, A inverse is 1 over determinant times the adjugate of A. That will be 1 over negative 1, which is negative 1, times the adjugate. We exchange these two. 5 come here, 1 goes there, and then give opposite sign to B and C. And then we simplify these two. We get, when you take 1 inside, you get negative 5, 2, negative 5 plus 2 plus 3, and then negative 1. So A inverse is what is, why does this happen? I don't know. A inverse will be negative 5, 2, 3, negative 1. Okay, now to check whether this is correct or not, we can check it by using this formula and see whether we get identity matrix or not. So A is 1, 2, 3, 5, and A inverse is negative 5, 2, 3, negative 1. When you multiply these two, you know how you multiply this row by this column. You follow the structure. So 1 times negative 5 is negative 5, 2 times 3 is positive 6. Next one is again this row times this column. What you will get is 1 times 2 is 2, 2 times negative 1 is negative 2, and then you multiply second row by the first column, which will be 3 times 5, negative 15, 5 times 3, sorry, will be positive 15. Cool. Then last one, again this row by this column, you get 3 times 2, 6, 5 times negative 1, negative 5, and as you see, you'll get 1 here, 0 here, 0 here, 1 here, and that is identity of 2. That means this was true answer, the correct answer, A inverse. Next example is this example. So as you see, first we will need to find a determinant, which is 2 times 3 is 6, minus 6 times 1 is 6, which is 0, and oops, you know that determinant, if it is 0, then you cannot find inverse. So A is not invertible, since why? The reason is determinant of A is 0. For this reason, you cannot find the inverse if you get determinant 0, because in the formula you cannot plug it. Before last example is this matrix A. So first, again, we need to find a determinant, which is negative 5, sorry, positive 5. Reason is 0 times 2 minus 5 times negative 1. That will be 5. Now the inverse will be 1 over the determinant times the adjugate. Adjugate is we exchange the place of A and D and give opposite sign to C and B. To simplify this, you get 2 over 5 here, 1 over, sorry, that will be negative 5 times 2 in the denominator will be negative 2 over 5, negative 1 over 5, 1, 0. That will be the inverse. So A inverse is what? Is negative 2 over 5, negative 1 over 5, 0, 1. Now you can check it yourself by multiplying A with A inverse and see if you get identity of 2 by 2 or not. I did check it myself and I got it, so you can do the same thing and be sure that we got correct answer. Last example says find the value of k for which this matrix A is not invertible. Now not invertible means determinant of A is 0. In such cases it is not invertible. So first we need to find the determinant of A, which is k 2 positive 2 negative 2 k plus 5. That will be k times k plus 5 minus negative 2 times 2. That will be k square plus 5k plus 4. You know that you can put this into bracket, factor it, so it will be k 4 and 5 both positive will be plus 4 plus 1. Okay, and if we want to find where it is not invertible, where the determinant is 0, we make this 0, and from here you know that k is either negative 4 or k is negative 1. So what is the conclusion for these two value, negative 4 and k is equal to negative 1? The matrix that we have, the matrix A, is not invertible. But for any other value of k, let's say 0, 5, 4, 1, 3, it's gonna be okay. It's going to be invertible. You can find a determinant, it will be not 0. Okay, but for these two, negative 1 and negative 4, it will be 0 and you cannot find a determinant. So that's it about the inverse of 2 by 2 matrices. We will stop here. You can do the same steps to find the inverse of other 2 by 2 matrices. In the next lecture, we are going to learn how to find the inverse of 3 by 3 matrices.